Welcome to Space Secrets English. I'm Mr. Sufayan, and today we're resoaring into the outer reaches of our solar system with NASA's groundbreaking Interstellar Mapping and Acceleration Probe by IMAP, launched on September 24, 2025, aboard a SpaceX Falcon 9 from Kennedy Space Center's Launch Complex 39A. This $150 million spacecraft, built by Johns Hopkins Applied Physics Lab, isn't just another satellite. It's a cosmic cartographer designed to map the invisible boundaries of the Heliosphere, our sun's protective bubble, while decoding the solar wind's chaotic symphony. Riding alongside the Carruthers Geocorona Observatory and NOAA's SWFOL-1, IMAP blasted off at 7:30 a.m. ADT, beginning a 2-year journey to the Sunarthal Satu point, a million miles from home there. It will deploy 10 revolutionary instruments to create the first real-time 3D atlas of solar wind flows, energetic particles and the heliosphere's EGR region, spanning 100 astronomical units, 3 times Pluto's distance. Why chase this ethereal frontier? The heliosphere shields Earth from 90% of galactic cosmic rays, but its shape, strength, and reactions to interstellar space are still riddles. IMAP's data will supercharge space weather forecasts, protecting satellites, astronauts, and power grids from solar tantrums. Let's dive into the mission's blueprint, its tech arsenal, and the forecasts that could save billions. IMAP's roots trace to the 1950s, when Eugene Parker predicted the solar wind, a million-mile-power torrent of protons, electrons, and ions erupting from the sun's corona, inflating the heliosphere like a balloon in a storm. Voyager probes crossed its boundary in 2012 and 2018, revealing an asymmetric, comet-shaped shield with a blunt nose and streaming tail, but their distant, one-off snapshots left gaps. Selected in 2017 as NASA's 5th solar terrestrial probe, I am appealed by Princeton's David McComas unites 25 global institutions. The 2,000-pound probe, a solar-powered cube, launched on Falcon 9's reusable booster, which landed flawlessly for its 24th flight. Solar electric thrusters will fine-tune its path to L1 by January 2026, where gravitational balance lets it stare sunward uninterrupted. Unlike aging sentinels like ACE or SOHO, IMAP's iAlert system delivers live data streams, cutting warning lags from hours to minutes. Its prime mission: 2 years of relentless scanning, extendable to 5, capturing the heliosphere's breathing through the solar cycle. The instrument suite, a masterpiece of precision. IMAPILO, the low-energy neutral atom imager, sweeps the heliopause, bubbles turbulent rim crafting, all sky inner maps at 1 degree resolution. These neutral atoms, born when solar wind protons steal electrons from interstellar hydrogen, slip through magnetic chaos to reveal the boundaries contours. IMAP high zooms on high-energy ENAs, spotlighting acceleration zones at the termination shock, where solar wind decelerates from supersonic to subsonic. The magnetometer MAG untangles draped magnetic fields, warped by galactic pressures, while SWAPI dissects solar wind's elemental mix: helium, oxygen, pick up ions from beyond. Dust Analyzer, DDA, counts interstellar grains, ancient supernova relics, while ultraviolet spectrograph UVs probes distant glows in the heliotail. CONI sniffs neutral interstellar gas directly, and IMAP images solar energetic particles from flares. Together, they simulate the heliosphere's dynamics, how it shrinks in solar maximum, exposing more rays, or expands in quiet phases. IMAP's solar wind map is revolutionary. Flowing at 250 to 800 kilometers per second, the wind sculpts the heliosphere into a teardrop, nose toward the galactic center, tail opposite. Instruments trace its coronal birth magnetic reconnections, flinging particles, then its slowdown at the bow shock. 90 yaw out, compressing interstellar plasma. ENAs highlight holes, rare alignments where wind punches through. A 10 billion to 1 cosmic lottery. Sampling these quantifies leakage, radiation risking, Mars cruise or Artemis habitats. The mission's neutral focus bypasses charged particle noise, offering pristine interstellar views, where our system meets the galaxy's ionized void. Data flowing mid-2026 could explain the ibex ribbona, mysterious inner Arcavia, magnetic tubes, or local clouds. Space weather, IMAP's superpower, coronal mass ejections, billion-ton plasma bombs trigger geomagnetic storms, blacking grids like 1989's Quebec outage, or frying Starlink. Current alerts from ACE give 15 to 60 minutes. IMAP synergy with SWFOL1's imager and Carruthers scanner extends that to ours via I-alert oxygen spikes flag CME. Models predict radiation belt swelling, shielding Europa Clipper. For Earth, aviation reroutes, grid safeguards, billions saved. As Makoma says, IMAP closes the sun to interstellar loop, arming us against chaos. In a cosmos of exoplanets, IMAP guards our home. Will it reveal a leaky shield or Earth's rare sanctuary? Comment your forecast, like if heliophysics hooks you, and subscribe for Chaplin's Time Traveler next. Thanks for charting the void with Space Secrets. English. Stay radiant.